index into that particular entry. The last parameter that we pass to seek and read is just the size of each inode. Okay, so that should take care of this problem. So we get rid of the comments. And moving on here. Now this one here is a read block group descriptor table, and this one is a little bit more tricky than the other ones. This one is a little bit more tricky because if you read this part here, the block group descriptor table is located on the first block following the superblock. This will be the third block, which means index 2 on the 1 kilobyte block file system, or the second block for 2 KB or larger block file systems. So you have to be more careful, because when it says third block, because in terms of indexing it is 0 oriented, that means we have to use index 2. When it says second, it really means index 1. So that means the calculation has to be a little bit more careful. I will insert calculation of the byte offset to the block group descriptor table and store it in block group descriptor table offset. The calculation must work for all block sizes. In other words, you cannot assume that the block is 1K or 2K or 4K. You may assume the superblock is already read into the superblock member of the FS info pointed to by pinfo. Utilize existing helper functions. So that's a clue that you can utilize whatever we have implemented so far, or after this. Okay, first thing we have to do is to find out exactly what block size is, because that will help us branch to two separate branches. So we have to say block size fs info pinfo. If that equals to 1024, which is 1 kilobytes, we do it one way. Otherwise, we do it another way. Okay. If it is exactly 1 kilobyte, then we specify block group dt offset to be 2 times 1024. Okay. And otherwise, we say block group descriptor offset is block size fs info pinfo times 1. Well, we don't have to really say anything about times 1, but that's the offset. So that's how it should be done. You can, if you want to, can use a simplified version of this logic, but this works and it's relatively clear. So we'll just leave it as such, like this. And we have more stuff here. Okay, we have to switch insert expression to pay attention to only a part of mode, and mode is already read in here. Okay, so in order to accomplish this, we have to look at all the case statements to see which part of mode we are really interested in. You can see that everything here ends with 0, 0, 0, and but the most significant digit of these 4-digit hexadecimal numbers will range from 1, 2, 4, 6, 8, A, and C, which basically means that the most significant 4 bits of these 16-bit constants is useful. If you want to mask out all the other 12 bits and only leave the only leave the most significant 4 bits of these 16-bit integers to be remaining, we have to specify a bit mask. So the bit mask we have to specify is F000, because this will basically make sure that all least significant this will make sure the least significant 12 bits will all become zeros, because otherwise they won't match these constants. But the F here will basically make sure that bit 12 to bit 15 of the integer will remain exactly the same as they are in mode. So this will be the proper bit mask to handle this particular calculation. And let's see if we're still missing anything. I don't think we're missing anything anymore. So let's go ahead and save the file as a specific file name here, so I can actually compile the program and try it out. Okay, we'll go ahead and do it this way first, because I forgot one thing. I forgot to actually expand it to a folder, so I'll do that now. Alright, so we do have a file now for this, and we can switch back to our command line. Alright, so let's go to the folder. This file is the old one, so we gotta copy it from the other one into here to overwrite it. And then we make I didn't fix all the problems. Okay, in function read. Okay, let's close now. Okay, let's see, we go into this folder, we open the same file, and then we find out what's wrong with it. Okay, warning, passing argument 3 of lseek makes integer from, oh, okay, I think I know why. There we go. Okay, I used lseek in the wrong way because I have to remember to specify the last parameter. Okay. Oops. Okay, man, lseek. Oh, lseek does not need to store the location. So this one is wrong. We have to specify one of the constants. Seek underscore set is what we want. Seek underscore set. Okay. Save. Okay. And the second problem is int32 undeclared because I have forgotten the T. So this is on line 106. So let's go to 106, which is right here. And of course I copied my own template here wrong. It should be int32 underscore T. That's an easy fix. And then we have another one of the same nature, which is on line 128. Okay, so we go to line 128. 128 is here. Okay, int32 underscore T. And we have one more problem on line 130. Too few arguments to function seek and read. Okay, so we specify p info. We specify this could be it's a parentheses matching issue, or is it not? Seek and read requires how many parameters? 1, 2, 3, 4. I'm missing one.